Metacognition is thinking about thinking, but in practice it is more useful than that short definition sounds. It is the ability to notice your own understanding, strategies, assumptions, confidence, and errors while you are learning or working. It helps you ask whether you really understand something, whether your current approach fits the task, and whether your confidence is supported by evidence. Cognition is the mental work itself: reading, remembering, solving, deciding, writing, comparing, or troubleshooting. Metacognition is the awareness and regulation of that work. For example, solving a technical problem is cognition. Noticing that your first explanation depends on an untested assumption is metacognition. Writing a report is cognition. Realizing that the report is clear to you but not to the audience is metacognition. Metacognition matters because many important mistakes happen before the final answer. A learner may confuse familiarity with mastery. An engineer may keep applying the same strategy after evidence stops fitting. A leader may make a confident decision while missing uncertainty in the assumptions. A writer may produce fluent text without checking whether the claim is actually supported. The point is not endless self-analysis. Metacognition is a practical operating skill. It gives people a way to pause, check, adjust, and improve while work is still in motion. In learning, technical work, troubleshooting, leadership, writing, and decision-making, that ability can prevent small misunderstandings from becoming larger errors. A core metacognitive skill is knowing what you know, what you partly know, and what you do not know yet. This sounds simple, but it is often difficult. People can feel confident because a topic is familiar, because the explanation sounded clear, or because they have seen the same words before. That feeling can be useful, but it is not proof of usable understanding. Familiarity and mastery are different. Familiarity means something feels recognizable. Mastery means you can explain, retrieve, apply, compare, or adapt the idea when the source is not directly in front of you. A fluent explanation can hide weak comprehension if the person has not tested the idea through examples, application, or recall. Confidence can rise faster than competence when feedback is missing. Illusions of understanding are common in learning and work. A person may believe they understand a system because they can follow a diagram while someone else explains it. Later, when asked to troubleshoot the system, they may discover that the relationships were never secure in memory. The issue is not intelligence. The issue is that recognition felt like capability. To test understanding, ask the idea to do work. Explain it in your own words. Apply it to a new example. Retrieve the steps without looking. Compare two similar cases and explain the difference. Teach the idea to someone else. These tests make gaps visible, and visible gaps are useful because they tell you what to learn or practice next. Monitoring understanding means checking comprehension while reading, listening, practicing, or solving a problem. Instead of waiting until the end to discover that the thread was lost, you notice confusion as it appears. You pay attention to moments when the details stop connecting, when a term is unclear, when an assumption slips in unnoticed, or when progress is only superficial. This skill is especially important in complex work because errors can compound. A small misunderstanding in the first step can shape every decision that follows. In troubleshooting, a weak assumption can cause a person to collect the wrong evidence. In writing, an unclear claim can make the rest of the argument unstable. Monitoring lets you adjust before the cost of correction grows. Good monitoring uses questions. What do I think this means? What evidence supports that interpretation? Which part is still uncertain? What assumption am I making? Could I explain the last step without looking? What would I need to see to change my mind? These questions slow the work just enough to keep it aligned with reality. Monitoring does not mean stopping every few seconds. It means creating checkpoints at meaningful moments. Pause after a section, a decision, a failed attempt, or a new piece of evidence. If the material still makes sense, continue. If it does not, change the strategy, reread, draw a diagram, ask a better question, test the assumption, or seek review before errors harden. A useful signal is the phrase, "I sort of get it." That may be true, but it deserves testing. Sort of understanding is often enough to follow someone else's explanation, but not enough to act independently. When that feeling appears, convert it into a concrete check. Summarize the idea, apply it to a small case, or name the part that is still unclear. Metacognition also appears before the work begins. Planning means choosing an approach that fits the task instead of automatically using the same strategy every time. Different tasks require different methods. Learning a concept, debugging a failure, writing a recommendation, reviewing a design, and preparing for a difficult conversation all place different demands on attention, evidence, and time. Good planning starts with the outcome. What are you trying to learn, decide, produce, or improve? What do you already know? What is uncertain? What resources will help? How difficult is the task likely to be? Where should you place checkpoints? These questions help allocate attention and time before momentum carries you into the wrong approach. Strategy selection includes choosing when to use notes, examples, diagrams, checklists, experiments, retrieval practice, peer review, or a worked example. A diagram may be the right tool when relationships are confusing. A checklist may help when steps are repeatable and easy to skip. A small experiment may be better than another long debate when the issue can be tested. The practical risk is strategy autopilot. People often use the method that feels comfortable, not the method the task requires. A strong metacognitive habit is to pause and ask, what kind of problem is this? Then choose the strategy deliberately. That small moment of planning can save hours of effort that would otherwise be spent pushing a mismatched method harder. Reflection is structure review, not vague rumination. It asks what happened, why it happened, what was assumed, what evidence was used, what changed, and what should be done differently next time. Reflection turns experience into reusable learning. Without it, people may repeat events without extracting the pattern that would improve future performance. Self-explanation is one of the most practical reflection tools. Instead of only naming the answer, explain why the answer works, why a step matters, or why an error happened. In technical work, this might mean explaining why one root cause is more likely than another. In writing, it might mean explaining why a section supports the main claim. In leadership, it might mean explaining why a message created confusion. Comparing predictions to outcomes strengthens reflection. Before acting, make a prediction. What do I expect to happen, and why? Afterward, compare the result. If the outcome matched, ask whether the reasoning was actually sound or merely lucky. If it did not match, ask which assumption failed. This habit improves judgment because it connects thinking to evidence. Personal after-action reviews, learning journals, and decision notes can make reflection easier. They do not need to be elaborate. Record the goal, the approach, the uncertainty, the result, the feedback, and the adjustment. Over time, those notes reveal recurring gaps and useful patterns. Reflection becomes less about criticizing yourself and more about building a memory system for better work. Calibration means matching confidence to actual knowledge, skill, accuracy, or likelihood. Good calibration does not mean always being uncertain. It means confidence rises and falls with evidence. If you are highly confident, you should be able to point to why. If evidence is weak, confidence should be more cautious. Calibration helps people decide when to act, check, learn, or ask for help. Overconfidence is risky because it can stop checking too early. A person may skip testing, ignore feedback, or dismiss uncertainty because the answer feels obvious. Underconfidence is also a problem. It can prevent people from using real capability, taking appropriate action, or accepting useful challenge. Both problems distort performance because confidence no longer matches what the person can actually do. Prediction checks are a simple calibration tool. Estimate how likely an answer is, how well you understand a topic, or how successful an approach will be. Then compare the estimate with the result. Confidence ratings can also help. Before submitting an answer or making a decision, rate your confidence and note the evidence. Over time, you can see whether confidence is reliable. Feedback loops improve calibration when they are specific and timely. The point is not to punish being wrong, The point is to update beliefs based on evidence. Accurate self-assessment improves learning and decision quality because it helps you choose the right next action, continue, review, practice, test, slow down, or bring in another perspective. Metacognition makes learning more active. Instead of passively consuming content, the learner plans practice, monitors progress, uses retrieval, spaces review, seeks feedback, and adjusts methods. The learner asks what capability is being built and what evidence would show that the capability is real. This keeps learning connected to performance instead of completion. Planning practice means choosing the skill and the exercise deliberately. If the goal is better troubleshooting, practice may focus on hypothesis formation or evidence collection. If the goal is better writing, practice may focus on outlining or revising claims. If the goal is better communication, practice may focus on summarizing uncertainty or asking clearer questions. Monitoring progress means noticing whether the current method is working. Are errors repeating? Is the learner retrieving the idea without looking? Is the task too easy, too hard, or productively challenging? Has feedback identified a bottleneck? A metacognitive learner adjusts difficulty and strategy instead of assuming that more time with the same method will automatically solve the problem. This also helps learners know when to ask for help. Asking for help is more effective when the learner can name the target, the attempt, the gap, and the uncertainty. Instead of saying, "I do not get it," the learner can say, "I can follow the example, but I cannot choose the method on a new problem." That is a much better starting point for useful feedback. Metacognition matters in day-to-day work because real tasks are full of assumptions. In debugging and troubleshooting, it helps you ask what you have actually verified and what you are only assuming. In code review, it helps you separate surface familiarity from real understanding of the data flow or risk. In writing and analysis, it helps you check whether the evidence supports the claim. Teams benefit when reasoning is visible. Shared assumptions are easier to improve when people say them out loud. A useful team habit is asking, "What are we missing?" Another is naming uncertainty clearly. This is confirmed, this is likely, this is unknown, and this is the next test. These habits improve communication because they make confidence and evidence easier to inspect. AI-assisted work makes metacognition even more important. AI tools can produce fluent output, but fluency is not the same as correctness. A user still needs to check assumptions, sources, constraints, and uncertainty. Tool fluency can create the feeling of understanding because the answer arrives quickly and sounds polished. Verified understanding requires review, application, and evidence. A practical AI workflow includes metacognitive checkpoints. What did I ask the tool to do? What assumptions did the output make? Which parts can I verify? What evidence is missing? Do I understand the result well enough to defend or modify it? The goal is not to reject tools. The goal is to use them critically while keeping responsibility for judgment and understanding. This is also useful for delegation and review. When you hand work to another person or a tool, keep track of what standard the output must meet and how you will verify it. Metacognition keeps the owner of the task engaged. It prevents a smooth handoff from becoming a loss of accountability, context, or understanding. Metacognition helps people observe, evaluate, and improve their own thinking. It includes awareness of understanding, strategy, assumptions, confidence, errors, and feedback. It is useful because many learning and performance problems are not caused by lack of effort alone. They happen because people do not notice when their current method, model, or confidence is no longer aligned with the task. Strong metacognitive practice includes planning, monitoring, reflection, calibration, feedback, and strategy adjustment. Planning helps choose an approach before work begins. Monitoring catches confusion and uncertainty while work is in progress. Reflection turns experience into reusable learning. Calibration keeps confidence connected to evidence. Strategy adjustment changes the method when the current method is not working. The goal is not endless introspection or harsh self-criticism. The goal is better learning, better judgment, clearer decisions, and more reliable performance under real conditions. Metacognition gives people practical checkpoints. What do I know? What am I assuming? How confident should I be? What feedback do I have? And what should I change next? Used well, metacognition makes people more adaptable. It helps learners avoid passive content consumption, helps professionals catch weak assumptions, helps teams communicate uncertainty, and helps AI users separate polished output from verified understanding. It is a quiet skill, but it changes the quality of the work because it improves the thinking that produces the work.